Hello friends, welcome to video lecture on first module from Dynamics of Machinery course. Under this module, we'll discuss about these points: classification, function of governor, Watts governor, Porter governor by using method of resolution. Under this module, we'll cover the two different points. First one is nothing but governors and second one gyroscope. So under these governors, we'll discuss about introduction to centrifugal and inertia governors, then force analysis of governors. It includes Porter and Hartnell governor. Next, performance characteristics of governors. Then next, governors effort and power. Then the classification of governor. Governors can be broadly classified into two types. First one centrifugal and second one inertia governors. Centrifugal governor may further be classified as centrifugal governors, pendulum type and loaded type. The pendulum type is further classified as Watt governor. Then loaded type is further classified as deadweight governors and spring control governor. Deadweight governors further classified as Porter governors and Proel governor. And spring controlled governors further classified as Hartnell governors, Hartung governors, Wilson, Hartel governors and Pickering governors. As far as concerned with the syllabus, we'll focus only on this Watt governor, Porter governor and Hartnell governors along with these sub points. Then we'll see the function of the governor. So the function of the governor is to regulate the mean speed of an engine when there are variations in the load. For example, when the load on the engine is increases, its speed is decreases. Therefore, it becomes necessary to increase the supply of working fluid. On the other hand, when the load on the engine is decreases, its speed increases and thus less working fluid is required. The governor automatically controls the supply of working fluid to the engine with the varying load conditions and keep the mean speed within the certain limits. The centrifugal governors are based upon the balancing of centrifugal force on the rotating balls by an equal and opposite radial force known as counterlinked force. It consists of two balls of equal mass which are attached to the arms as shown in figure. These balls are known as governor balls or fly balls. The balls revolve with the spindle which is driven by engine through bevel gears. The upper ends of the arms are pivoted to the spindle so that the balls may raise up or fall down as they revolve about the vertical axis. The arms are connected by the links to a sleeve which is keyed to spindle. This sleeve revolves with the spindle but can slide up and down. The balls and sleeve rises when the spindle speed increases and falls when the speed decreases. In order to limit the travel of the sleeve in upward and downward directions, two stops S and S are provided on the spindle. The sleeve is connected by a bell crank lever to a throttle valve. The supply of the working fluid decreases when the sleeve raises and increases when it falls. When the load on the engine increases, the engine and the governor speed decreases. This results in decrease of centrifugal force on the balls. Hence, the ball moves inward and sleeve moves downwards. The downward movement of the sleeve operates a throttle valve at other end of the bell crank lever to increase the supply of the working fluid. Thus, the engine speed is increased. In this case, the extra power output is provided to balance the increased load. When the load on the engine decreases, the engine and the governor speed increases, which results in increases of centrifugal force on the balls. Thus, the ball move upwards and the sleeve raises upwards. This upward movement of the sleeve reduces the supply of the working fluid and hence the speed is decreased. In this case, power output is reduced. Then, inertia governor. In this type, the position of the balls are affected by the forces set up by an angular acceleration or deceleration of the given spindle in addition to centrifugal forces on the balls. Using suitable linkages and springs, the changes in the position of the ball is made to open or close the throttle valve. Thus, whereas the balls are operated by the actual change of engine speed in the case of centrifugal governors, it is by the rate of change of speed in case of inertia governors. Therefore, the response of inertia governors is faster than of centrifugal types. But simplicity of centrifugal governors makes them more popular. Then we'll discuss about the terms used in governors. Height of the governor. It is the vertical distance from the center of ball to a point where the axis of the arms intersect to the spindle axis. It is usually denoted by H. So this is the distance from the center of the ball and where the both arms are pivoted. Okay, this is the vertical distance. Then equilibrium speed. It is the speed at which governor balls, arms, etc. are in complete equilibrium and the sleeve does not tend to move upward or downwards. Mean equilibrium speed. It is the speed at the mean position of balls or the sleeve. Maximum and minimum equilibrium speeds. The speed at the maximum and minimum radius of the rotation of balls without tending to move either way are known as maximum and minimum equilibrium speeds respectively. There can be many equilibrium speeds between the mean and maximum and the mean and the minimum equilibrium speeds. Sleeve lift. It is the vertical distance which the sleeve travels due to change in equilibrium speed. Whatever the moment of this sleeve, that is nothing but the sleeve lift. Now we will discuss about Watt's governor. This is the simplest type of centrifugal governor, that is a pad governor. It is basically a conical pendulum with the links attached to a sleeve of negligible mass. So it consists of the various parts such as arm, link, a sleeve, spindle, then a fly balls. So the arm of the governor may be connected to a spindle in following three ways. The first one, here the arms are directly connected with this P point or spindle axis. Here the pivot point may be offset, but when produced that meet at point O. Here once again it may be offset, but arms are cross on each other. So in this case the weight of the arm, link and sleeve is neglected as it is very low in comparison with the weight of this fly ball. Let M indicate the mass of the ball in kilogram, W indicate the weight of the ball in Newton, so must be equals to mg. So T indicate the tension in the arm in Newton, omega indicate the angular velocity of the fly ball and this arm along the spindle axis. Then R is nothing but the radius of the path of rotation of the ball in meter. This is the horizontal distance between the center of this fly ball and the spindle axis. Fc indicate the centrifugal force of this fly ball must be equals to m omega square r, and h is nothing but the height of the governor, that is nothing but the center of this fly ball up to the pivot point. This ball will remain in equilibrium under the action of various forces such as a centrifugal force Fc acting on the ball, then the tension T inside of this arm and the weight W of the ball. Now taking the moment about this point O by the various forces, then taking the moment about this point O, we have Fc, this will turns about this point in clockwise direction, and this one W turns about this point. If I take the moment of this W about this point O, this will turns about this point in anti-clockwise direction. So Fc multiplied by H, Fc multiplied by this distance H equals to W multiplied by this R. So we know this W is nothing but the mg. So we can replace this mg for this W and Fc by this one m r omega square. So here in this case m and this r term common for both the side, so that get cancelled, and here we can get h equals to g divided by omega square, where g is expressed in meter per second square and omega is in radian per second. Then h in meters, if n is the speed in rpm, then omega equals to 2 pi divided by 60. So from equation number 1 we can just substitute the value of this omega here, and we can get this relation h equals to 9.81 divided by 2 pi divided by 60 whole bracket square. So after simplification we can get h equals to 895 divided by n square. Here g is nothing but 9.81 meter per second square. So in this we can get the relation for this h equals to 895 divided by n square in terms of meter. In this case, if you look towards this n which is in denominator and as well as its square. So whenever the speed of that engine is increases, automatically the height here is decreases. So for smaller change in that speed, this governor not responds. So basically this will works for the low speeds very well, might be in a range of 60 to 80 rpm. Now we'll move towards a next part of this lecture, that is analysis of Porter governor by using method of resolution. Porter governor is the modification of Watt governor. Here the central load is kept on this sleeve so that the fly balls comes at the predetermined level quickly. Here for doing the analysis, consider the forces acting on one half of the governor as shown in figure. So this indicates the pre-body diagram of this configuration diagram. So As per our earlier discussion in case of VAT governor, the various notations we have used such as let M indicate the mass of this fly ball. So W is nothing but the weight of that fly ball. Fc indicate the centrifugal force acting on this ball. T1 is nothing but the tension in arm. T2 is nothing but the tension in the link. Capital W indicate the weight of the central load. Alpha is nothing but the angle made by this arm with the vertical axis, that is spindle axis. And then beta is nothing but angle made by this link with the vertical axis. N indicate the speed in RPM. So there are the different methods to get the relation between height of the governor and the speed of the governor. But as far as concerned with our syllabus, we'll focus on the two methods. First one, method of resolution, and second one, instantaneous center method. So in this case, just consider the equilibrium of the forces acting at point D we have. So if I consider the force acting on this D in downward direction, that is W by 2, and in upward direction is nothing but the component of this T2 in vertical direction, that is T2 cos of beta. So we can simply write here T2 cos of beta equals to W divided by 2. W can be replaced by this term mg by 2, or you can simply get the relation for this T2 like this: T2 equals to mg by 2 cos of beta. Now again consider the equilibrium of the point B. This point B will remain in equilibrium under the action of four forces. First one, the weight of the ball acts in downward direction. The centrifugal force Fc acts in outward direction. Then the tension in the arm T1 and T2 in the link. Okay. Then resolving the forces vertically and equate the same. So in this case, it is very important to resolve the this one, tension T1 as well as T2 along the horizontal direction as well as in vertical direction, like this one. So vertical component of this one, T1 is nothing but T1 cos of alpha, and here T1 sine of alpha. Similarly, the component of this one comes along the horizontal direction as T2 sine of beta, and the component along the vertical direction of the same T2 here cos of beta. Now focus only on the vertical forces, T1 cos of alpha. So T1 cos of alpha in the vertical direction, that's why the plus sign given for this one. So equal to both, actually this one, these forces are in downward direction, that's why written towards the right side of the equation. So T1 cos of alpha equals to T2 cos of beta. So component of this one, T2 in the vertical downward direction, is nothing but the T2 cos of beta plus this one, weight of the ball in downward direction, that is small w. Now, so what's about this one, T2? T2, already we get the value for that T2. T2 is nothing but the mg by 2 into cos of beta. So replace this one T2 by this term. Okay. So T2 cos of beta is nothing but the mg by 2 here, and this w is nothing but mg. Now resolving the forces in horizontal direction by considering this B as center point. Now focus only on the horizontal forces. The two components with us here. The first one T1 sine of alpha, and the component of this one in horizontal direction is T2 sine of beta. So you can get the equation like this one: T1 sine of alpha plus T2 sine of beta equals to FC. Now further modification in the equation, you can get this relation. So replace this one T2 by this term, and we can get the modification in the equation like this one, T1 sin of alpha plus mg, this one sin of beta divided by cos of beta is nothing but the tan of alpha equals to FC. Now you can get this next relation, T1 sin of alpha equals to FC. FC will remain as it is. Take this terms towards the right side, so you can get this relation. So equation number 3 for this one. Now dividing equation number 3 by equation number 2. So T1 sin of alpha equals to this term will come here, and next one T1 cos of alpha is nothing but whatever the term towards the right side, just simply write here. So T1 get cancelled. Sin of alpha divided by cos of alpha is nothing but the tan of alpha. Take this term here, okay, this term will remain as it is here. Now take this tan of alpha towards the right side, so it goes in denominator, here also in denominator, okay. Now substituting tan of beta by tan of alpha equals to Q, and tan of alpha equals to R divided by H. So what's about this R divided by H? If you look towards here, R is nothing but the radius of rotation and H is here. So on focusing this geometry, we can get tan of alpha is nothing but R divided by H. So we have just substitute the value of tan of alpha here, FC here, and for this one replace by Q. Okay, so mg by 2 plus mg equals to, just replace this FC by m r omega square multiplied by this h divided by r will come for this one tan of alpha. So minus this term will remain as it is, and for this one Q will come here. Now in the next part, you can get the relation for this m omega square h here, r get cancelled. Take this term towards the another side. So after simplification, so what we get here, you can get the relation for the h. So keep this h here, take this term towards the right side. Okay, so h is nothing but small m plus capital M by 2 into 1 plus q divided by m multiplied by g divided by omega square term will occurs. So what's about the omega square? Omega square, simply take this omega square here and h here. Now after putting the value of omega equals to 2 pi n divided by 60, we can get the relation for this n square like this one, m small m plus capital M. This term will remain as it is, this one as it is. Okay, by substituting the value of omega equals to 2 pi n divided by 60 and this g equals to 9.81, we can get this relation for n square. So in this case, when P and D, so here is the P and here is the D, when this P and D on the vertical axis, on the same axis, then the value of this alpha and beta becomes equal. So when the value of alpha and beta becomes equal, so what we get here, tan of beta by tan of alpha is nothing but tan of beta by tan of alpha equals to, what we get here, simply Q equals to, we can get the 1. So if I substitute the value of Q equals to 1 into this equation, then what we get, n square equals to small m by 2 into 1 plus 1, means here 2 get cancelled, capital M by small m multiplied by 895 divided by h. Now when the frictional force is considered, then equation number 5 and equation number 6 is changes like this one. So in place of this one central load, that is the W by 2, when we consider the entire load, then we need to consider the frictional value in addition with that central load. So this equation can be modified like this one, n square equals to mg plus m capital Mg plus minus f by 2 into 1 plus q divided by mg multiplied by 895 divided by h. Now if we focus on equation number 6, only change occurs here. Okay, so you have to just add plus minus this one, you have to add the value of this one force here. That is the frictional force. The direction of the frictional force or the value of the frictional force F is need to be considered positive or negative, depends upon the motion of the sleeve. If the sleeve moves in vertical upward direction, then the frictional force will act in downward direction, and you need to consider the plus sign for that. Whenever the reverse case happens, then you need to consider the negative sign for the same. Now, when we compare this relation with the weight governor, so height of the governor will be changes in the ratio of small m plus capital M by n. I hope in the today's lecture concepts regarding function of the governor, terms used in the governor, Watt's governor and Porter governor, analysis of the same by using method of resolution cleared you. In the next lecture, we'll discuss about the next type of doing the analysis regarding Porter governor, that is instantaneous center rotation method, and Hartnell governor. Thank you.